welcome all the students for the day 11 for the course cyber security. Okay, today we are going to see just one topic in third unit, that is network layer. In that we are going to deal with the routing fundamentals. So after completing this, we will move on to the fourth unit by tomorrow. Okay. Okay. So the objective of today's session is to make you known about the fundamentals of routing concepts, and the outcome is that the students may be able to understand the fundamentals of routing concepts. Okay, these are the outlines that we are going to deal in today's session. First, we'll be dealing with the definition of routing and what are the vendors available for routers and what is the format of routing table and what are the components of routing. There is three components are available. One is algorithm and routing table, that is going to be a database table, and routing protocol. So all these comes under routing components. Okay, and what are the metrics for routing? We are going to see that. What are the types of routing protocols available? And next thing we will be dealing with types of routing algorithm. So that is static routing algorithm versus dynamic routing, and source routing versus hop by hop, and centralized versus distributed. The last one is distance vector algorithm versus limb state routing algorithm. Okay. Okay. So let's see first the definition of IP routing. So routing in the sense we are in the router will do the process of routing process, that is it will move the packet from one network to another network. Okay, that's the main process of router. Okay. So router means it's a networking device which makes the connection possible between the two or more different networks present at the same location or at a different location. So that's the main purpose of router. Okay, and this router works on the third layer of the OSM model, that is network layer. And the basic functionality of router is first one, it selects the best path from the routing table, and best path in the sense it will choose the optimal path which satisfies the certain criteria. That is, it will also meet of the cost effectiveness, and it also selects the optimal path among the several paths available. Okay, that was the first function of the router. And second function is it forwards the packet on the particular route. So here some of the vendors of router is listed here. Many companies are manufacturing routers. Their first one is Cisco, Nortel, Multicom, Juniper, D-Link, Freecom. So these are some of the vendors of routers. And Cisco is the leading manufacturer of routers and switches. So it manufactures 70% of routers and switches of the market. Router is a hardware device which sends the packets and receives the packets to other networks. It's used for sending and receiving, forwarding the packets to the other network. Okay. So here you can see routing is to choose or select the best cost-effective path. Best cost-effective or optimal path that will be done by applying the routing algorithm on the particular router. Okay. So here here you can see this diagram. In this you can see some of the numbers or associated with each link. Okay, that number is called as cost. So each link or edge is associated with cost. That refers to the cost of the path. Okay. So suppose if A has to reach the destination C, then it has many routes to send. So A node will select the best path. Okay, so what is routing means? It is going to find the path from one source to another source, from one source to another destination. Okay. So routing is functionality that's going to be occurring at the layer C, and the bridging is the functionality occurring at the layer 2, the data link layer. Okay. So routing is one of the most important functions of the network layer, which is used to route the packets from source mission to destination. So network layer at the source will create packet that is coming from the transport layer. So the above layer of network layer is the transport layer. So from the transport layer, data will be passed on to the network layer. In the network layer, the data will be created as a packet. So the header of the packet will be containing the source IP address as well as the destination IP address. Okay. So network layer is more responsible for checking its routing table to find the routing index. That has to forward the packets to the next network. That will be done by the router. Okay. So at the destination point, the same network layer will be responsible for the verifying the address, whether the destination address matches there. It makes sure that the destination on the packet is similar to that, the same as that of the host station at the destination point. Okay. So if the packet is divided into so many fragments, then at the destination it has to wait until all the fragments of the packet assembles there. So after reassembling all the packets, then it will forward the reassembled packet to the next higher layer, that is transport layer. So this was the functionality done by the at the destination point. Okay. Okay. So coming on to the performance criteria, the selection of the route will be based on some criteria. That is, the first criteria is to choose or select the minimum cost. Yes. Is it not visible? Okay, let me check once again. Okay, fine. Let me continue. Okay. So the first criteria is to choose the minimum hop route. What do you mean by a hop? So hop means if the packet is transferred from one network to another network via the router. So if the packet is going to pass on one router, that is going to be a one hop. Okay. So the second criteria is cost. So the cost is associated with each link. Okay. The next thing, so how will you go for calculating the hop count? So here in this picture you can see, so from one network to another network, R is connecting these two networks. So that is called one hop. So from R2 is connecting two networks. That is one hop. Okay. So in this way you can go for calculating the hop count. So hop is nothing but defined as the passing through one router. If it is passing one router, then it is going to be called as one hop. Okay. If it is going to be passing through if the functionalities. First, it will search for the matching host address. So host address in the sense MAC address, then it's the physical address, then it will search for the matching network address is IP address. Then it will search for the default entity. Okay. So all these routing will be done by IP router, and it goes on searching for the routing table. So whenever the packet reaches the router, it goes on with the routing table, and it will take the routing decision, and it will forward the packet based on the destination address. Okay. So here you can see the network router. Some connections were made here. So router is connected to computer, printer, game station, high-speed internet, and so many devices are connected to the help of the router. Okay. In the second picture, you can see so for PC1, PC2, PC3, PC4. So all the systems are connected via router. Okay. So here you can go. The router will do the routing process, wherein which whenever the data packet reaches the router, it will forward to the next network. So the first circle, it defines the network 192.168.0.0. See, the first PC1 is representing the address, IP address is 192.168.0.1, and PC2 is 0.2. So we can club this PC1 and PC2 in the network 192.168.0.0. On the other side, we can club these two PC3 and PC4 as another network. Since it starts with the 192.168.1.0. Okay. So from that, if any packet reaching from if the source address is PC1, it is going to forward packet to PC4 via the router. The router will do the routing decision whether it goes to it has to forward the packet to PC3 or PC4. So it will be checking with the routing table, and the destination IP address will be checked. Okay, based on that, the forward the packet with the corresponding destination. Okay. So routing table. So what is routing table? We can simply say this routing table as a database table. Destination, network destination. Okay. So the main metric used here is distance. So distance associated with the host. So the routing table is very containing information. First, it will have the destination address. Next to point, the IP address of the next to hop address. Next to hop router. Then network interface to be used. Subnet mask for this use for the interface, and the distance to the destination. So these are the following information will be maintained in the routing. Okay, so what is the subnet mask? So it is with the IP addressing. So for that content, I have telling some information about IP addressing. Okay, so we can go classifying IP addressing in two ways. One is classful addressing, the other one is classless addressing. Okay, so what is classful addressing? It's going to have some any types in that. Okay, so usually an IP address is 32-bit address, which uniquely or universally defines the connection of a host. So whenever you go for referring a host division, you will refer that particular host division with the help of the IP address, which is the 32-bit address. Okay, the address space of the IPv4 is 2/32. So which was introduced by IANA, that is Internet Assigned Numbers Authority. Okay. So this 32-bit address is divided into 4 equal parts of 8 bits. So that is going to be separated by a dotted decimal notation. So each 8 bit will be separated by a dot. each 8-bit is going to be called as the octet, one octet. So one octet is going to be called as a 1 byte. So 8-bit is nothing but we can go by referring 1 byte or 1 octet. Okay. So IP address is going to be in the format of 4 octets or 4 bytes or 4 8-bit representation. Okay. The parts which are included in IP address are the first part is your network part and the second part is your host part or blueprint part. Okay. So how does the IP address look like? The structure is going to be having 4 sections. So each section will be of 8-bit long and the section can range from 0 to 255. For example, if you write the IP address is 128.35.0.7. Okay. So here you can have 5 different classes of IP address. Okay. So class A, class B, class C, class D, and class C. Okay. For class A, the IP address is going to range from 0 to 127. And for class B, it's going to range from 128 to 191. And for class C, it's going to range from 192 to 223. Okay. Then class D ranges from 224 to 239. And for class E, it ranges from 240 to 255. Okay. So the first octet, it defines the class of a particular IP. So for example, if you take 128.11.3.31. So in the 4 octets, you can take the first octet. Okay, first byte you can see. So it is representing 120. With that number, you can check it with the ranges. So it falls in class B. The ranges of class B addresses will be going to from 128 to 191. So you can easily say that this is the class B address. Okay. And 127.0 to 0.0.0 to 127.255.255.255 is the range of the loopback address. We call that particular address as the loopback address. So we have seen 5 classes of IP address, and each class is for specific function. Okay, so class A is going to reserve for government, and class B is reserved for medium companies will be using this class B address, and class C will be used by the small companies, and class D is reserved for multicasting purpose. Class C is reserved for the future use or used for research and development projects. For that purpose, class E address will be used. Okay. Coming on to this, class A address ranges are specified here. Okay. And the class A will be supporting 6 million hosts on each 127 networks. And class B is going to be from 128. 1.0.1 to 191.55.255.25, and it supports 65,000 hosts on each of 16,000 networks. Okay, and class C will be supporting 254 hosts on each of 2 million networks. Class D used for multicast groups, and class E used for research and development purpose. Okay. So here you can see each first octet. Already we have seen IP address is going to be of 4 octets. First octet will be converted into a binary thing and binary conversion. Then if the first bit is 0, then it comes to class E. The first bit is 1 and second bit is 0, then it goes to the class E. If the first bit is 1, second bit is 1, and third bit is 0, that is 1, 1, 0, it falls on the class B address. For class B, you can go for representing 1, 1, 1, 0. So that is representing class B address. for class B, 11110. That is representing class E address. Okay. So class A address, the IP address of class B will be ranging from 0 to 126 in the first octet. The first octet is representing the network path, and the remaining all three octets define the host part. So normally IP address is divided into two parts. One is the network part, and the second part is host part. So class B is going to have up to 8 octets is going to representing the network part, and the remaining 3 octets is going to represent the host part. Okay. So it is denoted by IP part 8. So this 8 representing the network part. Okay. And for class B, it ranges from 128 to 191 decimal value in the first octet, and the first 2 bits defines the network part, and the remaining 2 octets represent the host part. Okay. The patterns will be like this NN, that is first 8 octets. Sorry. 2 octets will be representing the network part, and the remaining 2 octets will be representing the host part. Okay. First 16 bits, when you are considering the bits representation, first 16 bits representing the network part, and the remaining 16 bits representing the host part. Okay. And it is denoted by IP for 16. So the private network IP ranges from 172.16.0.0 to 172.31.255.255. So in general formation, it can represent bar 12. Coming on to class C, it ranges from 192 to 223 decimal value in the first octet. Okay. And first 3 bits defines the network part, and the remaining 1 octet, first 3 octets will be representing the network part, and the remaining 1 octet representing the host part. That is, the pattern will be looking like N, 3 octets representing the network part, and 1 last octet is representing the host. Okay. This is denoted by IP part 24. Okay, class B ranges from 224 to 239 decimal value in the first octet, and it's not usually in the general applications. It's specifically used for multicast applications. Okay, and class E ranges from 240 to 255 decimal value in the first octet, and it's not usually used in general applications. Mainly it's reserved. This IP address is reserved for the research and development department, okay, R&D department. So usually we will be any PC or any host will be supporting the first 3 classes from class A to class C, and class D and E is not supported. Okay, it is specifically reserved. So here you can see class A first octet is representing network, and the remaining 3 octets representing the host. So 8 bits is going to be your network part, and the remaining 24 bits representing the host part in class A. So totally IP is of 32 bits. So we are going to divide for each and every class. 32 bits is divided into corresponding patterns. Okay, for class B, 16 bits are representing the network part, and the remaining 60 bits representing the host part. And for class C, 24 bits representing the network part, and 8 bits representing the host part. The same thing, the ranges is given in this tabulation, which you have already seen. Okay, so that will move on to the next slide. Okay, here also representing the same thing. 32 bit network part and host part. IP address is divided into these two. If the network part is comprising of first 2 octets, then it's going to be a class B address. So 176.10.255.255 is going to be a class B address. Okay. So what will be subnetting? So subnetting is going to be a solution, or it's the process of dividing the bigger network into some smaller network. For example, if you are using any university network that is going to provide some schools that can be used for schools, library, and medical school, then so for each it can add on some additional level to the hierarchy of the IP addressing structure. So that is called as subnetting. That is, so already the IP address is going to be divided into two parts. One is network part and the host part. So coming on to the subnetting, the IP address is going to be have three hierarchy. Okay. So basic idea of subnetting is that IP address is going to be divided. That is, the host number portion of the IP address is going to be divided into subnet number and the host number. Okay. So normally we will be having network part and the host part. In subnetting concept, the network part will be there. The next part, subnet number will be there, and host number. Okay. So then the subnet can easily be assigned within the organization. Okay. So the subnets are going to be treated as a separate network. So this network structure will not be visible to the outside the organization. Okay. So what is the advantage of subnetting is that you can view IP address in three level of hierarchy. The first one is network, subnet number, then subnet, and host number. Okay. So this improves the efficiency of the IP address, not by consuming the entire address space for each physical network. And also, the main thing is that the advantage of using subnetting concept is that it reduces the complexity of the routing router. Okay. So the external routers do not know about subnetting, the complexity of the routing table and external routers is reduced. So next on the classless IP address. So far we have the classless IP address and different types of classless IP address. We have the class from class A to class E. What constitutes classless IP address? So the process of giving the classless IP address is called as CIDR. So CIDR is representing classless inter-domain routing or routing rotation. Okay, classless inter-domain. So this was announced in the year 1996 and which allows the ISP, that is Internet Service Providers, to assign some more IP address as requested. So based on the request classless IP address was announced in the year 1996. So two terms are used in this classless addressing. One is prefix and the other one is prefix length. So prefix is going to be the another name for the common IP address range, that is net IP, and prefix length is referring to the length of the prefix. Okay. So in classless addressing, the last address in the block does not necessarily end in 255. Okay. So when the classful or the address ends in the 0 to 255, whereas it's not the case in classless IP address. In CIDR notation, the block branch is defined by the first address and the prefix length. Okay. So in fixed length subnetting, the number of subnets is power of 2. Okay. So here we can view the subnet mask table. So whatever we have /1 is representing the mask address 128.0.0.0. Up to 8/8 you can see 255.0.0.0. So that is representing your class A address. Okay. And bar 16 representing class B and bar 25 representing the class C and bar 32 representing the class C. Okay. So address and the colors, they are representing the default mask for the class A, class B, class C. So thus classful address borrow. So this normal IP address structure is going to be the standard class address structure is expanded by borrowing the bits from the host portion to allow for more number of networks. Okay, so subnet routing is the concept where we are going to borrow the additional bits from the host portion in order to focus on the more number of networks. Okay. So this subnetting is to separate the network and the host, which requires in the process that is going to call the subnet masking. Okay. So subnet masking process was developed to identify and extract the network part of the address. So you're going to extract the network part from the address. Okay. So a subnet mask which contains the binary bit pattern of 0 1 and it is applied to the address to determine whether the address is on the local network. If it is not so, the process of routing is to an outside network begins. Okay, if the subnet masking is not carried out, then it will the router will forward the packet to the outside network. Okay, so here you can have the for each default subnet mask is represented here for class A, class B, and class C. So these subnet masks will be applying only to class A, B, and C IP addresses. So subnet mask we can call this as a filter that is applied to the destination IP address. So the main objective of subnet mask is to determine if the local network is the destination network. We are going to check for the destination network. Okay. So where the router has to forward the packet to the corresponding destination network. So subnet masking will help in such a way to forward the packet to the destination network. Okay. So here for an example I can take this destination IP address 206.175.162.21. So from the first octet 206, we can clearly identify to which class it belongs to. So what is the range of the class C? 192 to 223 is the range of class C address. So 206 falls in between. Okay, so we can clearly identify this following IP address belongs to the class C address. Okay, and its binary equivalent is given below. Okay. So next thing we have to go for representing the default subnet mask for the class C. So default subnet mask is represented 255. So class C address will be comprising first 3 octets as the network part and the last one is your host part. So first 3 will be represented as subnet mask as 255.255.255. Okay. So then next binary equivalent is described here. Okay. Now you are having 2 binary representation. One is the given class C address binary equivalent, and the other one is the default subnet mask is here. Okay. So now you are going to combine these 2 IP address and the subnet mask, or combine using the Boolean addition. That is, you are going to perform the AND operation to get the. So the resultant will be the IP address of the network, which in this case is the same as the local network. Okay, and which means that the message is for a node on the local network itself. Okay. Okay. So for the concept of subnet mask, I have gone through some IP addressing concepts, wherein which we have seen a class full addressing scheme and classless addressing scheme, and how the subnetting mask is done. Okay. Now we are going to see the format of the routing table. So routing table is going to have the first field is going to be a mask. So this field is the defined the mask applied for the entry. Then the next field is your network address. This defines the network address to which the packet is finally delivered. So in this case, the host specific routing. In case of host specific routing, the field defines the address of the destination host mission. Okay. So this network address will be defining the destination IP address. Okay. Next field is next hop address. So already we have dealt with what is meant by hop. Okay. Next hop address means this field defines the address of the next hop router to which the packet is delivered. Okay. Interface. This field defines the name of the interface. Next comes the reference count field. This gives the number of users. How many number of users are using this route at this moment? That will be described as reference count. If the value 5 is represented, then it says that 5 people at the same time are connected to the same host from this router. Okay. Then the next field is use. This field shows the number of packets transmitted. So how many number of packets are transmitted through this router will be defined with the use field. Okay. The next field is flag. So here you can go for setting of 5 flags. The flags are going to be on or off switches that signify the whether presence or absence. Okay. The 5 flags of U, that is up, and G representing gateway, and H is host specific, and D is added by redash, and M is modified by redash. So what is U flag representing? It indicates the router is up. That is, it is up in the sense it is in the working condition. If the flag is not present, then it means that the router becomes false. The router is down. So that no forwarding task is not going to be done by the router. Okay, it means that. Okay. Then G representing gateway. The G flag means that the destination is the another network. Okay, the packet is delivered to the next hop router for delivery. That is your entire delivery. So when this flag is missing, then it means that the destination is within the particular network directly. So if G is on, it shows that it represents the entire delivery. That is the router has to forward the packet to the another network outside the network. If G is if this flag is missing, then it's going to be a direct delivery. Okay. Next H, host specific, indicates that the entry in the network address field is the host specific address. When it is missing, it means that the address is only the network address of the destination itself. Okay. And D is added. D indicates the routing information for this destination has been added to the host routing table by a redirection message from the protocol, that is ICMP. Okay, next M means this flag indicates the routing information for this destination has been modified. So routing table is modified by the redirection message from the protocol called ICMP, Instant Control Message Protocol. Okay. Next comes to what are the components involved in routing processes. So there are three important concepts to be discussed. One is routing algorithm. The next one is routing table, that is the database entry, that is routing table. Next comes the routing protocols. Okay. So protocol is a way in which the information for routing to be gathered, the information can be gathered and it can be distributed to the other networks. Okay. So what is routing algorithm? So whenever the packet reaches the router, it has to take the routing decision. That is, it has to communicate or it has to verify the routing table. And so routing algorithm has to be applied at that moment. So it has has to, the routing algorithm has to specify certain criteria. It has to satisfy some criteria. What is the optimality? That is, it has to compute the best route, best path. Okay. Then the algorithm should be a simple one, or it should have a very low overhead. Very low overhead. That is, the algorithm should be efficient one with the minimum software, and the utilization should be a best one. Okay. The next comes the robustness and stability. So the algorithm should perform in a correct manner in focusing or in dealing with the unusual circumstances also. Okay. So despite any circumstance, it has to work. The algorithm should work. That is, that brings the performance. Okay. Then rapid convergence. So rapid convergence means whatever the algorithm you are going to apply, it should respond quickly depends on the network changes. Okay. The algorithm should in such a way it has to adapt to the network changes also. The next one is flexibility. So flexibility in the sense if your the algorithm should produce an accurate result based on the variety of networks combined together. Okay. Next comes the routing protocol. So protocols normally used to exchange information, packet information or data information from between the routers and about the current state of the network. Okay. So the routing protocol will do the functionality of creating the routing table entries and keeping the updation in the routing table, and it also chooses the best path for the next hop. So routing protocol will do all these jobs. So it is the main role in creating the routing table and updation of the routing table, and it also goes for the best using. It has to do the best optimal path also. Move to the optimal path. So what are the routing metrics to be followed? So maybe limits, maybe a distance, and throughput. Throughput in the sense how far getting the response. Okay. And delay in the transmission, error rate, cost. So these are going to be the routing metrics. So based on this metric, the router will decide which route to be selected for the next forwarding the packet. Okay. So this will become the measurement to compute the route, which route can be a best one. Based on this metric, the router can do the job. Okay. Now the routing protocol is going to classify into two types. One is static routing protocol. Under the static, you can have the type of fixed routing protocol, and the next one is dynamic routing protocol. Under the dynamic routing protocol, you can have two types of one is distance vector, the other one is link state. So under the distance vector, you can have classification RIP, IGRP. RIP means routing information protocol, and IGRP is interior gateway routing protocol. Okay, so under the RIP, that is routing information protocol, can have versions V1 and V2. Two versions are available. And under the link state, you can have EIGRP, that is exterior internet gateway routing protocol, and OSPF. OSPF is open shortest path first protocol. Okay. So these are the classifications of routing algorithm also. So static routing and dynamic routing. What is meant by static routing in the sense the routing function will be decided by the network administrator. So he is is the whole sole responsible for routing the packets. So the static routing means it will be using a programmed route. That is, you will be having one fixed route. They only one route. Along that route, the router will be forwarding the packet to the next network. Okay. Dynamic means you can go for changing the alternative path while forwarding the packet to destination. Okay, based on the network topology changes or anything circumstances changes, dynamic routing can be fixed. Okay. So what is static routing in the sense it contains the information which will be entered manually. Okay, the administrator, that is network administrator, enters the route for each destination into the routing table. So whenever the table is created, cannot be updated in between or automatically when there is a change in the internet. So that the static routing table will be monitored and it won't be changed. This will be maintained by the network administrator. Or the table will be altered manually by the network administrator. Okay. So what are static route operations? It needs three parts. One is network administrator, who is sole responsible for configuring the routes. So they will be selecting the best path. Okay. Then the router installs the route in the routing table, and the packets will be routed using the static routed IP routes. So here you can see A router and B router. Okay. So there is going to be only a single network connection between these two. The connection is going to be a point-to-point connection or circuit switch connection, no other path. So you cannot go for changing the other path in case of static routing. Okay. So what is in the default routing? So default routing, suppose if A and B in one network and C is another network. So from B, it has to forward to this C network, C router. So from B, it has to decide router has to forward the packet either to in the same network or to the internet, some other network. So at B, it has to do the routing decision. Okay. So if no other information is provided, no entry for the destination network, then the B routers can be selected as the default route. If suppose A to C, the packet is going to be transferred from A to C. Okay, then it is selecting B as the default route. So why there comes the need for dynamic routing? So if any changes occurs in the network or changes in the topological structure, then there comes the alternative path to be chosen. So we are moving to the dynamic routing protocol. Okay. If A to C the destination, A is source and C is the destination, then if A has to pass through either B or D. If D is not suitable, then it has to select the alternative path B. For that, dynamic routing protocol is used. Okay. So static I already have discussed. So what is under static can have the concept of flooding. Flooding means whenever the incoming packet arrives at a particular router, it has to flood. The thing is that it has to retransmit to the every other nodes to the neighbors. So every packet which is arriving at the router will be sent out as outgoing packet. So retransmission on all outgoing at each node is done here. That is flooding. Okay. So it requires no network information. It goes on forward to the neighbors. Okay. So there will be this spreading causes number of duplicate packets to the neighbor nodes. Dynamic routing table is updated periodically by using one of the dynamic routing protocols such as, so what are the available dynamic routing protocols? RIP, obviously that is routing information protocol, OSPF that is open shortest path first protocol, or BJP is border gateway protocol. So these are some of the dynamic routing protocols useful for dynamic routing. Okay. So whenever there is a change in the internet, such as if the router becomes shut down, or if it is breaking, any break in the link occurs, then we can move for dynamic routing protocols and update all the routing tables in the routers. That will be done automatically. So here are some of the examples of routing protocols are listed: RIP, IGRP, that is Interior Gateway Routing Protocol, and EIGRP is Enhanced Interior Gateway Routing Protocol. Okay. So the routing protocol plays a main role, which is enhancing, or it's used for performing the communication between the routers. So it allows one router to share the information with the other router with the help of the routing protocol. Okay. So what does this dynamic routing operation? So it depends on two basic router functions. One is first the thing is the routing table will be updated automatically based on the network changes, and the second thing is timely distribution of the knowledge in the form of routing updates to the other